Hey guys, welcome back to this lecture, Run Prometheus Ecosystem in ECS Cluster. In this lecture, we will learn how we can run different Prometheus components in the ECS containers, and we will see how we can integrate them with other services running in our AWS account. Okay, so for this demo, we will monitor your EC2 machines. Okay, we will implement the integration between your MSK discovery service with the MSK cluster so as to auto discover them. Also, we will see how we can integrate the CloudWatch using the CloudWatch exporter. Apart from that, we will be using hotel collector as well. We will use it to talk to our Prometheus endpoint that is running in the Node.js application in our ECS cluster only, and then we will set up an integration between hotel and AMP directly. Okay, so we will be using the open source Grafana service to create the visualization, and as a data source it will be using the AMP for the time series data. So guys, this is the architecture. In the upcoming lectures we will deploy and create these containers one by one, and we will also set up the discovery mechanism in the cluster, and we will see how this works. So I'll not take much time here. Let us quickly jump onto the demo now. Okay guys, so here on the screen you can see we are in the ECS console right now. The very first thing we will do is we will create the Prometheus cluster. Okay, so let me quickly do it. I'll use the EC2 Linux plus networking template here. I'll give it the name, let's say Prometheus demo cluster, and provisioning model I'll keep on demand. EC2 instance type I'll take the medium one so that we do not cause much cost to our account. Okay, so let me just quickly go to the v2.medium. Okay, number of instance I want one only. I'll be using the default AMI and everything will be default REST. I'll use the existing VPC. I'll select the subnet here. I don't need a public IP, so I'll leave it as it is. In the security group, I'll be using the default one, existing one. Now container instance role, I'll be using this ECS instance role. I'll go next and create it. So let it create quickly. So here you can see it is creating the CloudFormation stack for us. So you can directly destroy the environment using the CloudFormation stack as well, which it is deploying for us. Suppose that you'll just have to delete the cluster. Okay, so these are all the resources details which it has created for us. So now currently it is creating auto scaling group for us. So, okay, so the entire stack is completed. Now let us go to the cluster quickly. Okay, so our cluster is ready guys. Now it is the time to deploy the task definition for us. So let us quickly go to task definition. Let us create a new task definition here. I'll be using the EC2 because in the backend we want our workload to run on the EC2 instance. I'll give it like Prometheus demo task definition. I'm giving it as TD. Okay, task role I'll be using this Prometheus task role. So guys, throughout the upcoming lectures in this lecture we will see what are the permission for these task roles and the security group rules associated with security group, so don't worry about it. In the network mode I'll be using the bridge because I want to use the bridge network in my EC2 and the containers. Task execution role, I'll be using this ECS task execution role. Task memory, let's say I want to give 1204, let's say, or yeah, that's fine. It should be, I want to give 1 GB, or maybe I can give 2 GB as well because I do have T2.medium, so it's fine. CPU as well, I'll give 2048. Okay, now it's time we create the container definition. So before that, what I'll do, I'll create a volume for us. Okay, so these are the volumes which we will create and where we will mount our containers. So let me quickly go to the container, and here I'll give it the name as config. Okay, I'll use the bound mount and source path. This will have to give as, just a second guys. Okay, so guys, in this demo we will not use the bind mount. Instead we will be using the EFS storage. Okay, so let us quickly change it to EFS, and we should, let me get the EFS endpoint for this. So I need to provide the file system ID. So let me quickly copy it from here, or let us not. Okay, that's fine. We'll be using the existing one only. I'll select the file system ID here. This is the access point, and root directory I'll keep at /. So this is the root of that. Okay, I don't need to, or I don't want to enable any IAM authorization or encryption, although you can enable the encryption if you want, that's fine. Okay, so this is the config volume added here. Now it's time we create our containers. So the very first container we will be creating for is Prometheus service. Okay, let me bring the image name here, which we'll be using for our container. Our first container, we'll say. Okay, so the image I'll be using is Bitnami image. Okay, this is a verified image from Docker Hub, so you can use it for your Prometheus service, and the version I'll be using is the latest one. Okay, I don't need the authentication because it's a public image. I'll give the memory limit here, let's say 1024, and port mapping I need is 9090 for my Prometheus container. Apart from that, let me just go down here, and so we will be creating a link here, guys, but I'll show you in the next few minutes which link we will be creating here. So let us go to the mount points now, and let us create a mount point for our Prometheus here so that it can persist its data inside the EFS volume which we mounted just behind that. Okay, so here I'll give the path of the container directory which I want to mount on my EC2 instance. OPT Bitnami Prometheus and then conf. Okay, I'll create another mount point, and it is for the data of our Prometheus container. OPT Bitnami Prometheus data. So these are the two source container directories which I want to mount to my EC2 instance. So I've given the path here. Let me quickly check the spelling here. Okay, it's all fine. Now let us, if you want to enable, you can enable the log configuration. For this demo, let us enable it so that if there is any issue comes, we will be able to troubleshoot with it. Okay, now I'll use the privileged user here. Although, guys, this is not the best practice in respect of security, but so as to I'm just using it so as we do not get into any issue because of the permissions. Okay, so let us quickly. Okay, so we don't need the resource limits, ulimit and all. We'll be using the default one. I'll not use the key value pair, so I'll add it. Okay, now the second container I need, and it's for Grafana because this we'll be using for the visualization. So let us quickly create it, guys. Grafana, and the image I will be using is from the Docker Hub OSS Grafana. Okay, and the version I'm using will be latest. Hard limit I can give, let's say 500 MB, let's say. So it should be fine for Grafana. And the port mapping I'll do. I want to map the 3000 port here. Okay, and now the next thing we need to do is we need to pass some environment variables. If you remember, which these environment variables we have passed in the Docker file of Grafana as well. So the same we will do here. So let me quickly pass it here. Okay, I'll use it as true. Now the next one is auth sigv4. So this environment variable is to enable the sigv4 authentication. Okay, so with this only, if you enable this, then only you will be able to use the sigv4 authentication while communicating with the AMP service. So I'll enable it as true. Now the next one is I need some other plugins. So gf install some plugins, and in the plugin I'll want to install Grafana clock panel. These are the assets, guys, which we can use. Okay, and the version I'll be using for this plugin is 1.0.1, and the next plugin I'll be using is Grafana simple JSON data source plugin. This is to enable the JSON data source. Okay, now 1.3.5 version I want to use for this. Okay, now the next environment variable is for log mode. Okay, and here I want to write the logs to console and file both. These are the same environment variable which we have passed in the Docker file as well. Okay, next one is for security admin password. This is the default password which goes. Okay, I'll pass it as, let's say, admin. Now the next is gf user allow sign up. So I don't want users to sign up in my Grafana, so what I'll do, I'll disable it. So I'll pass the false here. Okay, it should be yes, gf users allow sign up. Okay, we have passed it as false. Okay, now guys, because this Grafana basically depends upon the Prometheus container, right? So, or also you can say if there is any such requirement comes where you want to run a ECS container after another container comes up, then what you can do, you can use this startup dependency ordering. So what you can pass here, you can use the Prometheus. Let's say this is the other container which you want to run first, and you can pass the start condition here. So once this container will be started, then only this Grafana container will start. Okay, so this is how we pass the dependency ordering here. And now we need to create a mount point for this Grafana, and we will again use the same volume, and the path we will be using is where lib Grafana. So this is the path where Grafana stores all its data like plugin and console libraries and everything. Okay, next you can enable the log configuration as well, so that we get the logs. And I'm passing security privileges here. Okay, I'll just add it now. Okay, now it's time we add our third container, which is for, let's say, CloudWatch exporter. Let us try this one now. Add container. I'll give it the name CloudWatch exporter. The image I will be using is from Prom. So this is the image. Okay, now we need to give the memory limit. Let's say I want to give 500 MB for this, or this is just an exporter, so I don't even need this much. Let me pass it 256 only, that is 0.4 GB. Okay, now the port mapping. For port mapping, I'll give its default port 9106. Okay, now guys, you might be noticing what is this essential argument here in the environment. So essential basically means if you are enabling it, then your container is essential for this particular task. So if your container goes down, then entire task will go down. Okay, so that's why essential is kept here. If you can also disable it, so what will happen in that case, if out of 8 containers this container goes down, your task will keep on running and the other containers will come up successfully. Okay, so now the next thing we need to do is we need to create a mount point for this, because we want to pass a configuration file this CloudWatch exporter is. So we'll pass it from the config volume. Okay, so let me make it like config. I'll enable the CloudWatch logs for this, and now I'll just add it. Okay, now we need the next container. Now the next container we will enable the MSK discovery, guys. So for that we will create a container, and guys, this is a custom image we will be using. Or let me do one thing, let us create it later, because I want to show you few steps which will be helpful for you. Okay, so let us do it later. And then apart from that, for rest of the components we will go step by step. Okay, so let us first create these and let us start our task on this task definition, and let's see if it is coming up fine or not. Okay, so I'll create it here. So my task definition is created. So guys, I'm thinking one thing. Let's do one thing. Let us create a new EFS for us. Okay, and then we will be using that EFS to mount our task. Okay, I'm doing this because this EFS we have already created a lot of data inside this, because we were using it for the Prometheus DB in the previous lecture. So let us create the new one so that we do not mess up with the things. Okay, so let me Prometheus demo EFS. Okay, VPC I'll keep the same. Let us quickly go next. Okay, I want the one only, and the subnet I have chosen was, okay, we can change that later as well. So let us create the mount point in all, or mount target in all subnets, because I don't know like which subnet we have used for the cluster. So we'll change it later as well. So let this file system come up. Meanwhile, let us do one thing. Let us create a service here in our cluster, and that service will be managing the desired number of count of our task. Okay, so here I'll be using the launch time as EC2. Task definition already showing up here. Okay, it has picked the default one which is present there. This is the cluster. I'll give the service name as Prometheus demo and then service. Okay, I'll use the replica here. Number of tasks I want is 1. Okay, and I'll keep the other configuration as default. I'll go to next. Again, I am not using any load balancer behind this, so I'll not use this. I'll just go next step. Auto scaling I don't need, so I'll just click on next and we'll create the service here. So this service is created here, guys. So let us go to the service here. You can see it from here as well. Okay, so let us see now if the task is up or not. Let us go to task here. You can see there is no task. Let us see in the stopped state if there is any. Okay, we can see the task is failing because of some reason. Let us quickly check what is the reason. Okay, so now error response from daemon, create ECS Prometheus demo TD. Okay, volume driver, create mounting volume, failed. Okay, failed to resolve file system. Okay, so it is failing at the EFS because it was not able to resolve the mount point. Okay, now check that file system ID is correct and ensure. Okay, so let us quickly go inside the task definition here, and let's see for the volume that we have used or the file system we have used. Let us create a new revision here. Let us go inside this, and we have used the earlier one. Okay, let us change it to the new file system which we have created for this demo. Let us update it now. Now let us create it. Okay, now let us update our service to have this new task definition. So every time you are creating a new task definition and you want to reflect the changes here, so what you'll have to do, you'll have to change the task definition. Okay, I don't want to, what I'm doing, 1 second. Okay, yeah, okay, so just select 2 here, next, and the last update service. Okay, now we go to service. Okay, let me change the desired count here as well. Let us make it 1, and let's see if it is able to resolve it now or not. You can see the progress of your deployment in the deployment section here. Okay, so what it is doing, it has completed the active one, and this is the in progress right now, which you just deployed, or the changes we have just deployed. Let us see the task here. It is in pending state. Let us click on it. Let's see if the containers are coming up or not. Okay, it might take some time. Let it finish. Okay guys, so our task is in running state now, and we can see one container is failing here, and this is the CloudWatch exporter container. Let us check the log for this container and let's see what is the issue it is facing. So let us go to CloudWatch exporter logs here. It is saying exception in thread, file not found exception /config YAML. Okay, so guys, it is not currently able to find this config.yaml file here, which is needed by this container to select the metric that it will scrap from the CloudWatch. Okay, so we will create this file and then it will come up. So let us do one thing. Let us resolve this first and then we will create more containers, okay, which we need in our ecosystem. And also let us try to okay, seems like it is creating and then it is failing. So let us check if CloudWatch container is the essential one. If it is essential, then it will fail our entire task if it fails. Okay, so it is true, guys. This is the same thing. So our one container is failing, which is causing the entire task to fail. So let us do one thing. Let us update the task definition and make it non-essential, so that it does not fails our entire task. So I'll create a new revision here. We'll go to CloudWatch exporter, and here I'll disable it. I'll update. I'll create. Now the definition we have is the third one. Let us go to our service and then update the task definition over there. Update. I'll take the latest one. Next, 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 and update service. So let us go to our service now. Okay, it is in progress. Let us go to tasks. Let the new task come up and then we will see what happens now. Okay, so let it just, so here we'll see it. Okay, it came up. Let us click on it. Okay, so now we can see all three containers are up and running. Okay, CloudWatch has failed here or stopped here because it is not able to find the config.yml file. That's fine, we will create it in a few minutes. Now let us see if our task is going down entirely or not. Okay, so let me go to the task here, and the task is up because we have taken this container out of the essentials list. Okay, so now it's just a generic container, so my task doesn't care if it fails or succeeds. Okay, so the Prometheus and Grafana is up now. So let us try to do one thing. Let us try to access these console for this Prometheus and our Grafana. Now guys, there will be one catch, I believe. Okay, so let us quickly check the security groups first. Okay, we are using the existing one, so we are supposed to have all the port already enabled in the security group. So let us quickly use the public IP to access the Prometheus. Okay, that's great. I can see it here. So currently it is using all the default configuration because I have not replaced it with the new one. Okay, and the same we'll check for the Grafana. Grafana is also coming up. Okay, I'll pass default credential first, then it will ask me to set the new password. So I will pass the new password here. So I'm using the default credential here, guys, so we do not forget it. Okay, so I'm passing it as admin. I'll submit it. Okay, my Grafana is also up now. Okay, that's great. So guys, now let us do one thing. Let us quickly go inside the EC2 instance which we have for this. Let us see if we are able to connect, and let us see what all we got in the EFS storage which we mounted in our system. Okay, and I'll also show you where it is mounted by default. So we are inside this ECS instance. I'll click on it. Okay, we'll see. Okay, so guys, by default when you create an ECS instance, so this is where all the volumes are mounted. Okay, so this is where you will be able to see your volumes. So let us quickly go inside one of these. So let us go quickly inside one of these path, lib ECS volumes, and here this is where it is mounted. So you'll be able to see all the so whenever you make a new revision, right, or any update, so there is a new directory created over it. Okay, so we are currently in the third revision, so I'll click on it. Okay, so here we can see everything which we have mounted from different containers. Okay, So this Grafana and this plugin and Grafana is coming from the Grafana container. Prometheus.yaml is coming from the Prometheus container, and this val chunk ahead, these are the part of your Prometheus. Okay, alerting again Prometheus. Okay, so this is where it stores the mounted data. Okay, so what you can do now, you can replace these configuration file here if you want, or you can customize it, and that will be reflected on the container, okay, or your service. So now it's time we start the CloudWatch exporter, and for that let me quickly bring up the steps which will be needed here. So guys, the very first thing we'll do, we will give the CloudWatch permission to our task role so that my container can communicate with the CloudWatch service. Okay, so let me check the task role and the permissions associated with it. Let me open it in the new tab. Okay, let's close this EFS here. It is unnecessary increasing the tabs here. Okay, so I'm in the permissions here. Okay, so I need to give the CloudWatch read-only access here so that it can read the data from there. Okay. Okay, that's great. So we are done with this. So CloudWatch permission we have given. Now it's time we provide the config.yaml file to our container so that it can read the configuration from there. Okay, so let us create the config file for our CloudWatch exporter. So guys, currently I'm inside my EFS storage. Okay, this is the path varlib ECS volume and then the name of the volume mount. So now here I will create a config.yaml file. So guys, this file is expected by CloudWatch exporter because from this file only it reads, okay, which metric I want to scrap from the CloudWatch. Okay, so this is where we pass the details. Let me show you one configuration file here, and in the upcoming lecture where we will actually learn more about the CloudWatch exporter, I will explain you how you can design this config.yaml file. Okay, so here I'm just passing the basic information about one of the EC2 metric so as to see the data, okay, or to bring this container up. So I will save it here. Now it's time I restart my task so that I can see whether my that container, third container, CloudWatch container is coming up or not. So I'll just stop this task. So my service will automatically create a new task so as to match the desired count. So, okay. So let it come up. Okay, it might take some time as well, guys, so don't worry about it. Let the new task being created. Okay, so it is created and in running state, and let's see for all three containers, these are in running state now. Let us check the logs as well for the CloudWatch exporter, and let's see if it is able to detect the file. Okay, so we are not seeing that exception again, so that means it has accepted our configuration file here, and now it is up and running. Okay guys, so this was about these three containers. Now we'll take a step forward and we'll deploy the new component of our Prometheus ecosystem. So guys, let us take the next component as the Go application where we have implemented the Prometheus. And why we are taking this, because we will use the hotel collector to monitor and to send the metric data for that particular Go application to our AMP workspace. Okay, so now let us create a new container here. Let me go to the task definition quickly. Here is the task definition. I'll create a new revision here, and I'll create one more container, and I'll give it a name as Go sample application. So guys, this is the same application which we used during the client libraries instrumentation demonstration. Okay, so in that lecture, if you remember, or if you have not seen that, please go through that. So in that lecture, we have used a simple main.go file, and we have instrumented it with the Prometheus client library. And then after the completion of the lecture, we were able to see the Prometheus metrics to monitor that Go application. So we are using the same code base. I just converted that to the Docker image so that we can use it here directly rather than passing the individual commands while creating the image. Okay, so the image path I will share. Just give me a second. Let me quickly pick it here. Here. Okay, so this is the image name, and the tag is latest, so I'm just passing it. That's fine. as it is a public image. Okay, just a second, guys. Okay, let me remove this because I've pushed it to the Docker Hub, so it is freely available. You can get it on this particular repository. Okay, and you can pull it from there. So as it is a public repository, so we don't need authentication again. I'll give it 128 MB only because I don't think it needs much. And this is again the default port that we have exposed for our Go application. Okay, so I'm just creating a mapping for that. And now the next, I don't need anything. I'll not make it essential because it's just a sample application which we want to monitor using the hotel. Okay, so I don't need the mount point here because I'm not passing anything from the outside. So I've already compiled that code base, and I just created a CloudWatch, the Docker image for that, and we are using it now. Okay, so I'll add it, and now let us save this, and let's see if our container comes up. Okay, and in case there any issue, we will troubleshoot that live. Okay, so let us update our service here. Let us change the revision to latest one. Go next. I will update the service here now, and now it's time we go to service again. So what it will do, it will stop the last task which was running and will create a new task here with 4 containers now. Okay, this is the last one. Let it change. Here also you can see it, guys. So the current task which is running is using the task definition 3. So the latest task definition we created was 4, so it will be reflected in few minutes. So let it just come up. Meanwhile, I'll pause the video so that we can save the time that our this lecture will take. Okay, so it is up now. It is in pending state, so let's monitor its progress. Okay, let these containers be created, and we'll then see our core sample application is running or not. Okay guys, so application is up now. Let us quickly validate if we are getting the metrics for this or not. So for this application we have mapped to 112 port. So let us quickly go over here and let us check on the local host if we are seeing the metrics for that. 112 and then /metrics endpoint. Okay, we can see the metrics here, so that's really good. So we are getting the metrics. Now it's time we scrap it using the hotel collector, and then we will export it from the hotel collector inside the Amazon managed Prometheus. So let us quickly update our task definition, create a new revision, and we will deploy a new container for the hotel. I'll add a container here. I'll give it the name hotel collector. I'll give the public image here which we have from AWS. Let me quickly bring it here. Okay, I'll limit it, let's say 256. I can now in the port mapping I'll give these 3 ports here. It is needed by this container 174317 and then 8125. Okay, now the next thing we need is the command that we need to pass to read the configuration file from our EFS target. Okay, so what do we want? We want to pass the configuration file from our EFS storage, okay, from our local instance, ECS instance, and then based on that configuration it will scrap and export the target. Okay, so now this is done. Now the next thing I'll do is I will pass an environment variable for our AMP endpoint or AMP remote write endpoint. So let me quickly bring the environment variable here. Okay, now in the value we can pick it from here. Let me just quickly go to AMP. I'll pick the remote write URL. I'll paste it here. Great. Okay, now the next thing we need to link our existing container, the application container, to this container so that it can read the data from here. Okay, so I'll create a link here. Go sample application colon. Let me just recheck the name and spelling. Okay, it seems to be good. Okay, now I need the mount point where I'll mount my configuration file. Okay, I'll enable the log configuration, so if any issue comes I'll be able to see the logs. Okay, I think I'm done with this. Now let us quickly add the container here. Let us create the new task definition. Now guys, there is one more thing, because here we are trying to export the data from AMP to the from hotel collector to the AMP. So our task role where the container is running should have the AMP permissions as well. So let us quickly give that permission to our task role. So this is my task role. I'll attach a policy here. I'll select for the Prometheus and I'll give this one. I'll attach the policy. I'll go back to my ECS. Okay, so this is my new task definition. So guys, you might be able to see like the number has changed now because this video is recorded in the parts and multiple demos can go on this system. So that's fine. So we have added our new container here. Okay, now it's time we update our service and then we check whether the container is coming up or not. And also guys, as we have mentioned, like we have given the path of configuration. Just let me quickly bring it up here in the hotel collector. So we have given this path and the configuration file path in our container. So we need this configuration file to be part of that path already in the host mount point. Okay, so I have already created the file there. So let me quickly show you that file. Okay, this is the file. Now I'll explain like what are these different sections. So in the extension, we basically enable the extension which we would need from the hotel collector. So we are enabling health check and the SIGV4 authentication extension here. SIGV4 is required to communicate with the AMP service from our Prometheus cluster. Okay, and now the next is receivers. In the receiver section, we basically give the endpoints from where hotel will receive the metrics. Like here we have enabled to AWS ECS container metrics, which is default for ECS. Okay, and it will expose all the ECS related metrics for us. And now the next one is Prometheus, where we will give the Prometheus endpoint and the Prometheus related scrap related configuration. Okay, if you can see it here, the metric path is given /metric and this is the target given. Now this is the target. In the host name I've given the container name which is running in my ECS. Okay, so core sample application, and in the port I've given 2112. Guys, you can also pass this configuration through the environment variable, and you can use the variable here, and then you can pass this value from the outside. Now here we have processors which processes the data that is coming from the receiver, and then we have exporter which basically exports the data. So now in exporter we have given the AMP endpoint here, and the authenticator we have used the SIGV4 authenticator. Okay, in the service we basically create the pipeline where we say, okay, this is the receiver, processor and exporter. So that's the same we have defined here. So we are not going very deep in this configuration, guys, because this is not the scope of this demo. So I'll save it. Now it's time we restart the service and see whether the container is coming up fine or not. Okay, so let me just quickly update the service first. It is the revision 14. I'll update the service. Service is updated. Now let me quickly stop the task that is already running. Okay, let the new task come up and let's wait for it. Okay, this is visible now. Let us click on it. Let us change it. Okay, so we can see all the containers are up. Let us quickly go to the logs and let us check for the logs on hotel collector. It is showing this 150 detected resources information. Let us refresh it and wait for a few seconds if it is showing any other log here. Okay, let us refresh it. Okay, that seems to be stable here now. Let us go to Grafana and let's see if we are seeing the data over there or not. Okay, so the very first thing that we'll be doing in the Grafana is we will create a data source here for our AMP so that we can get the data from there. So we'll set up a data source here. We'll click Prometheus, and in the endpoint we will give the AMP query endpoint basically. Let us give it here. Let us pass it. Let us remove the extra path from the trailing. Let us enable the SIGV4 auth, and we'll select the AWS East 1, not EU, it is US East 1. Okay, let us save and test. Okay, data source is working. Let us go to explore now and let's see if we are getting the metrics for our Go application or not. Okay, let's check for the Go threads metric. Let me manually select it because sometimes it doesn't take time. Okay, it is go underscore threads. So let us run the query here now and let's see if the data is coming for the new application or not. Okay, that's great, guys. So we can see the data for our Go sample application here. That means data has started pushing inside the AMP and now we are able to visualize it in the Grafana. So guys, this was about this integration. In this lecture we have learned how we can use the hotel collector to integrate and already implemented Prometheus endpoint. Okay, so we are using hotel to receive the data from Prometheus endpoint and then we are exporting it directly to AMP. So in that case our open source Prometheus is not coming into the picture. Okay, so guys, this was about this lecture. In the upcoming lectures we will implement other strategies, like we will see how we can monitor different services like EC2 MSK, and we will also see how we can set up the discovery for those. And at the time of MSK discovery we will add one more container inside this cluster and we will use that to create our MSK configuration file or the configuration file which will be read by Prometheus. So guys, I'll see you in the next lecture. Thank you.